Well, hello everybody. Welcome to Space Force Theater 5000. If our other participants tonight can turn on your video and unmute yourselves.
Hello everybody.
Welcome. Oh, and of course, in our standard way here, YouTube stream, but it does show that we're live and I can hear myself. So that's wonderful.
Yeah.
Hello, Sarah. How you doing?
Hey, what's up?
Hey, Jared.
Hey.
Not much. Whoa. Okay, now I'm suddenly into the slideshow, which is still full screen. We don't need that yet. Oh, going perfect. Like I said, our disastrous start is our normal beginning to the show.
Failing it.
Trying to
Yeah.
exactly. We tried any other way, it would not be Space Force Theater 5000. Anyway, well, welcome to the show, everybody. We'll let our audience slowly trickle into the YouTube stream. Tonight we actually thought it through, and I was attempting to start even earlier than I did, but boy, the fidgeting and fiddling I was doing over here was crazy. You don't think you're going to do it, and then you do. But we got here. We're here. We'll let folks join. But I'm happy. By the way, I'm Dr. David Reitzel, David at this show. Sometimes you'll hear folks call me Doc. That's my Burning Man nickname. Joining me tonight on our main panel is Sarah. Over in the. Where are you exactly in the background there?
Oh, yeah. So this is Mount Wilson, and a friend took this picture. He's an amazing astrophotographer, Blake Estes, if you want to know. And that right there is Comet Neowise.
Yeah, I would agree. Blake's pretty darn amazing. He's got some skills, and he's actually helped out Black Rock Observatory before with some amazing images that we might still owe him for those. Maybe I shouldn't bring that up. Anyway, these amazing images printed on metal. So if you want some really, really cool astronomy pictures that are going to last a really long time, contact Estes and Schmidt, and that's a toss-out. They did us a solid giving us these images. They were gorgeous. People out of Burning Man loved them, and they were resistant to the playa that destroys everything. And also tonight, Jared, welcome again. Thank you so much for being here again with us tonight. How are you doing?
Glad to be here.
It looks like you're on the space station, I think.
Well, I'm a little bit higher. I'm about 530 kilometers above right now. I got Hubble behind me.
That is Hubble, okay.
Hubble, and I got Story. I'm hanging out with Story Musgrave over here too. So, just no big deal.
Hi, Story. If you're watching the show, I doubt it, but we have friends that Story. There's a non-zero chance that he at some point could even be on the show, perhaps if we begged. Who knows? But I'm actually super thrilled that we have a guest tonight joining us, Dr. Kennda Lynch. We'll call her Kennda tonight, but when we introduce her, we'll see that. But she's here. Are you going to join us here? Pop in. I see things changing. There you are. Hello. And Dr. Lynch, thank you so much for coming in, Kennda. You're looks like you're at Mars, just like I am.
Just on the horizon, just kind of right on the edge of the horizon where you can kind of see the atmosphere on Mars. So you're very, very thin, but you can kind of see the glow.
I'm seeing some stratification in there. Is that real?
For this image,
I'm guessing it would be dust layers, if anything, due to the dust storms.
Dust layers. I mean, it's very thin, so I think you do have parts of the atmosphere. My colleague Herman Martinez would be able to tell you that a little bit more. He's kind of our atmosphere guy, so he'd be able to tell you that better. I focus more kind of on the ground.
Indeed. Well, I don't know. I've always been fascinated with Mars. It's one of the reasons I became an astronomer. The whole excitement over could something have been alive there in the past? Those Viking results that came back and said, we don't know, but there are those out there saying that it could be done other ways. And then, of course, that meteorite that fell and the Allen Mills meteorite that had those little things in it that looked like tiny little fossils, but then again, they were way smaller than the ones we find on Earth. But then again, they'd be from Mars, so why would they be? But then again, like, who knows? It's all these little bits of evidence. So you study this sort of stuff, though. You're an astrobiologist. What you said, geomicrobiologist as well, which says you studied here on Earth. So that's some seriously cool stuff there.
It's fun, but yeah, the Viking, and I gotta be the Viking results and ALH 84001, Allen Hills meteorite 84001. have both been kind of exciting things that kind of led me on the path to my career anyway. So we can talk about that a little bit more later. I know you guys got some other cool stuff to get into.
Well, we have a little bit we want to get to, but again, this show's pretty free flowing. We do what we want to do. But I did want to talk about there's been a bunch of action at Mars, so to speak, or aimed at Mars, things that we're trying to do. One that didn't go this year is the European mission, the ExoMars rover. It's been delayed for a couple of years, and the reason for that, and I didn't get a graphic for this one, unfortunately, but the reason for that is that Earth and Mars have to be in the right parts of the orbit. So if I'm describing it here, Earth goes a little faster than Mars does. So when we get back around to where we are, Mars isn't in the launchable spot. So we have to wait a second year, basically, for us to get realigned. How many months is it exactly?
Well, if we really want to make sure that we get there at optimal time, and we could send it any time, it would just take a lot longer to get there, right? So about every 2 years, Earth and Mars come into alignment, and they're like, I actually literally, you can't probably see it, but let me see if I can show it on my phone. I actually have it on my iPhone watch, actually has the orbits.
Oh my God, that's awesome.
You see the blue and the red dot, that's the actual real-time orbits of Earth and Mars. You can see how close they are.
I was going to say,
cool.
On mine, what are the complications on it there as well? I got it too. So
nice. This is so cool. Grant, you're giving me some serious.
You got to know.
You can forward the orbit too and reverse it. So I can.
So you can pick where it'll be. Now, so did you celebrate the day when the launch window kind of opened, when spacecraft started going? Did you look at your watch and be right on time?
I actually have it on my calendar as like launch. So yeah, nice. But that's it's kind of old habit from, because I started my career actually in human space flight, and so launch windows were part of human space flight all the time. So yeah, especially if you had anything going on launch or anything important, the launch window is just something you definitely want to get into as much as, and you kind of watch that launch window religiously. So yeah, I was very happy that we're in the launch window and nothing shifted to the right anymore because it was getting precarious. But I think we're on the road to seeing this baby off here next week.
Yeah, and of course we're talking about Perseverance, folks. That's the new rover that NASA, JPL, and well, you're at the Lunar and Planetary Institute. I should properly introduce you. You're a staff scientist there, and you've been researching little microbiomes in hypersaline areas here on Earth. So studying some sort of extremophiles, so to speak. We talk about those at Griffith Observatory, where the three of us have a day job. So we're familiar with that idea, but we'll get there in a minute. So we're in a launch. I'm getting ahead of myself because I'm excited to talk about it. But we're in a launch window here. So ExoMars didn't go. They got delayed by COVID, and maybe perhaps other problems. Maybe that was just an excuse. I don't want to call them out, but we don't have to go there.
They've got a great mission. They've got a great landing site, and if they didn't feel they were ready, the best thing to do is delay. If they feel like they're not ready, the last thing you want to do is launch and then have things crash. It's not fun. Yeah. So if they don't feel ready, they should delay.
Mars is not easy. I didn't put up that very sad graphic that just has spacecraft after spacecraft not making it there. Exactly. Many from the Soviet Union or Russia, but we've failed many times. The Europeans have failed. So it's a hard place to go. Part of that's because the atmosphere's thin, and yet the gravity's strong enough, you get accelerated down, but it's not strong enough to really give you much of an assist. So you can't slow yourself down with the gravity assist because you got to it's almost in that magical. Room to slow down, and big parachutes, big jets. So we went from big parachutes and big bouncing inflatable hugs to to a rocket, kind of a retro rocket kind of thing where we actually slowed that stuff down. But even with a rocket kind of helping us slow down, we still need a lot of room to slow down. So. Now I know the United Arab Emirates launched something called Hope. That's an orbiter, I believe. I don't think there's a lander on it.
It's an orbiter.
Which that's pretty cool. It made it off, and everything seems to be going well. But another one that launched, the Chinese launched a whole package. There's an orbiter, there's a lander, and I think there's even a little rover that reminded me of Sojourner. For those of you out there that remember the Sojourner rover. But Jared, do you want to tell us about that? Do you have anything to share? The launch was beautiful, by the way. I don't know if we can show you the footage, but maybe we could. Well, if you have the Chinese stream, we can pirate it. That's fine.
Yeah. Well, the hard part is getting the stream out of China, which yesterday when everybody was watching the launch go down, we were all basically looking at like 3 or 4 Twitter accounts that were sort of reposting what was put on Chinese, specific to China social media sites. And we're still like, you don't know if you can like fully trust it or not. But
well, I was watching the Everyday Astronaut stream. He can be entertaining. I think he's pretty decent with his presentation, and
yeah,
you know, he was switching back and forth, and I love that the streams were freezing on him. He's like, no, not now. So we were watching him watch the streams. But the Long March 5, it is a beautiful rocket, I have to say. I love the fact that the flames come out on an angle, and that's the solid rockets on the side, that the flames are a little bit off axis.
It's all hydrolox, so liquid hydrogen and liquid oxygen. So yeah, fully cryogenic first stage, boosters, and second stage.
Okay. Well, why the heck are they?
What did they launch on again?
It was a Long March 5 that they launched. It's their largest booster.
Oh, okay, gotcha.
Yeah, it's essentially like our Delta IV Heavy or a Falcon Heavy here in the United States.
The way I'm seeing Sarah's eyes move there, I think she's been Googling Long March 5 and Long
March 5
is maybe
I
ready
have to look it up myself.
No, Sarah's got it. That's part of what she does so well. And
well, I've got the New York Times images.
If anybody watched the launch, so you notice that the flames on it, they all come out a little bit of an angle. And to me, you're getting this loss, like a cosine loss for you trigonometric nerds out there, trigonometry lovers out there. But what it is the fact that you're not pushing straight down. You're pushing a little bit off to the side. So you're not giving all your force to the direction you're trying to accelerate. In fact, all 4 are pointing a little bit off and they all cancel. So it seems like you're just burning fuel for the sake of burning it at that point.
It may have to do with where they have the center of pressure and the center of gravity on their rocket. They may not be lined up correctly. You know, you see that with the shuttle. The shuttle was designed with that, with the space shuttle main engines, you know, sort of canted off at an angle away. So it had to contend with that. So that's why just before launch, you see the engines gimbal into place. And that's actually the computer figuring out where they need to go in real time, which is pretty cool that it does that just before launch.
Oh, it was very cool. I always wondered if it always looked like it should fly in loops or something with the way
What did they call it when the main engines kicked on before the SRBs went? The twang, I think.
The twang, yeah. The
right when it rocks right there.
Move forward and then
up and then yeah.
Yep.
Right. So. Well, anyway, I do know the Chinese they launched a lander, and it's going to make a bunch of measurements. I'm not sure what. Do you know, Jared?
You know, the Chinese National Space Administration has been
as silent as Jared is right now.
Yep, he's a little frozen, so I'll just say they're going to take measurements of Mars.
That's what they think. Okay, well, that explains why I haven't seen a lot about it.
Yeah.
So they're going to go there and take measurements of Mars, and then they're going to go drive a little rover on Mars. Now, I like that the rover had the little flapped out solar panels. They kind of unfold.
Yeah.
It looks
very Lunacod, you
fun.
know.
Very, very much. So anyway, I'm looking forward to that. It did launch, seems to be on its way. It didn't explode. The stage is separated. Everything seems to be all fine with that.
Yep.
But in addition, we are sending Perseverance, which is a NASA JPL's new rover that we were mentioning before. So, Sarah, what do you know a lot about that for some reason? Wonder why.
I may have done a little research on it. It's pretty fun. Just really quickly, if we want to get questions on YouTube, we need the chat.
Oh. Who knows how to turn that on?
Oh.
All right.
Oh, yeah. Whoops.
Here we go.
Well, why didn't somebody mention in the chat? Now, where do we turn that on? Anyway, well, Sarah, you explain. You go ahead and talk about Perseverance, and I'm going to look how to turn on the YouTube chat.
Why?
I honestly, I looked earlier, and I assumed it would just turn on like it has every other time.
All right, watching us learn in real time.
I know. Well, no, but Sarah, you should take over talking about Perseverance.
I'm loading my slides right now. It's a little wonky, but let's see. So I'm on a new computer.
Well, I'll say I'm super stoked about the rover going, but I'm not super stoked about having to get up at 4 a.m. to watch it happen. So
that's come on.
Yeah, because the window, at least for us here on the West Coast, opens at 4:50 a.m. on July 30th. So
MSL was kind of a similar thing where it was like at midnight, It was like really, really, really late at night, for MSL. So, but yeah, you kind of get used to it after a while. You're gonna have to get up at all hours to watch launches.
Yeah, it wouldn't be my first time. So
Yeah.
I'm going to be cheating. I'm going to be on the road toward the East Coast, so it'll be a little bit later in my day.
My challenge is I gotta get a 5-year-old up to watch it, and it's history, so he's gonna get up.
All right, well, this is highly annoying because they're claiming that it should be shareable link. No, don't delete it forever. We're live right now. Comments. Published. Newest first. All right, well, how do we turn them on, folks? So everybody hang in there. Yeah, I'm not seeing where to do this. It may be too late for us to turn on comments for this one. So, yeah.
Oh, that's lame.
That is totally lame. I don't know if somebody wants to create a chat that folks can log into somewhere.
Not sure how to do that.
Me either. Default units. See, I'm way off track here when they're asking me about what the default monetary units are. Like we've ever made any money on this. It's our 5th show ever, and you can tell by the professional level right now. Anyway, I'm going to stop looking for how to turn on chat because in typical YouTube fashion, it's incredibly hard to find. I've clicked on the comments thing, and it's full on. There's no way to turn them on at this point. I think there is a way to update it somewhere, but it isn't obvious, and I doubt anybody's entertained by this any longer. Comment 0.
Maybe we can have people tweet their questions, and then we can kind of keep an eye on Twitter.
Yeah, that's the best idea so far.
Maybe a hashtag SFT5K. Did I say that right?
Yes. So that's a great idea, folks. So why don't you tweet at us, or just tweet with the hashtag SFT5K. We're still waiting for Steve Carell to sue us. He hasn't yet. I've tweeted at him a few times. All right, well, Sarah, you ready finally? So, yeah, I don't know why that's disabled. That's quite annoying. We could invite everybody onto the Zoom session. That's terrifying.
Why not? Make it fun. Like Russian roulette. Let's up the stakes.
Well, the problem is that people in the waiting room can't chat. If they could chat, then I'd be fine with it because they don't
right.
know about it. But
and then we'd have them. Yeah, I get you. We could ask.
Take it away for a second here. Let's tell us what we got going on with Perseverance as a rover here.
Oh, right. So the engineers and scientists at NASA, they tend to talk about these spacecraft as if they're scientists because they're sending a robot to do the science work that we would like to have people do at some point in the future. But until it's safe to do that, we send a robot in our stead, and that's okay. And this is the one that's going next. May look a little familiar if you like Curiosity. This is the new little brother, and like my little brother, it's slightly bigger. It's fine. This is the Perseverance rover. Okay, so what's it got on there? Lots and lots and lots of cameras. 9 engineering cameras just for upkeep and making sure it lands safely. We got 7 landing cameras, 23 in all. And up at the top, we've got on the mast cam, we've got mast cam Z. Curiosity had a mast cam. This one is Z because it's cooler. This one is Z for zoomable. So Curiosity, we've all seen these amazing panoramas that it takes, like this one right here, the background. That panorama from Curiosity is multiple little frames stitched together. And the engineers and the scientists, they take each one of those little frames, and there are actually 2 frames per exposure. There's a wide field and a telephoto field, and they don't match. And because they couldn't make the wide field lens zoom in the engineering time that they had to work with. So they figured it out in the time since Curiosity was built, and now we get Mastcam Z. So when we make stereoscopic images of the Martian terrain with Perseverance's images, they're going to be so much better and so much easier to stitch into these amazing pictures. So I'm looking forward to even more awesomeness and some easier access VR from this mission, because with those stereoscopic images that are just much easier to manipulate, it'll be easier for them to really rapidly turn it around and give us the new location where Perseverance has just explored for us to explore. And also it lets them up their navigation software and their deep learning so that the rover itself will be able to pick its own path and its own targets even better, all because of making this one lens zoom. I just love all this stuff.
And you're still on the first slide here.
I know. So I'm just gonna blast through on the rest.
Along here. You don't have all day. We've got a guest that knows all this stuff's gonna tell us a whole bunch of stuff.
Right, I know. Okay, so really quickly, because well, ground penetrating radar, so you know what you're driving over. MOXIE, it's because.
Let's show us what the rover's gonna look like. We're still seeing Next Martian Scientist.
Oh shoot! It's not doing the thing.
Yeah, I know. That's what I'm trying to tell you.
Ow! It did it to me again.
Yes. Jared, why didn't you speak up? I was looking up how to enable the chat on a YouTube, and it's impossible. Thanks, YouTube. We need a Twitch stream, I think, everybody. So we're going to Twitch one next.
I was unaware. I was the only one who was aware.
Ah. Anyway, all fine. So step through these. Here it is. It looks a lot like Curiosity.
Yep.
Next slide.
Like Curiosity. Yes. And it's got all these cameras. And one of them is really, really important. Mastcam Z, taking this panorama. Alrighty. And then RIMFAX is ground penetrating radar. Oops, there we go. RIMFAX is ground penetrating radar. So you can get an idea of the structure underneath. Which is something Curiosity didn't have access to. And MOXIE is our first attempt. I'm pretty sure, I'm guessing, but I cannot come up with another instance of attempting to terraform another world. MOXIE.
Well, I was going to say, it's not necessarily terraforming, but
yes,
it's trying to do a technology demonstration to make sure that we can do what we're pretty sure we've tested on Earth we can do, and that's doing what we call in situ resource utilization. So even before we get to terraforming, if we send our astronauts to Mars for the first mission, we can't send them with everything that they need. So we're going to have to use Martian resources. And in particular, the number one thing we're going to need is water. Water is very heavy. It's very good for shielding, but we can't carry all the astronauts would need for a 2-year mission, including, getting there, being on the ground for a year and getting back and all that. So we have to be able to use in situ resources for water for the astronauts to use and to create fuel to get them to come back. So this is a technology demonstrator to show that we can actually do it on Mars in a situation where the astronauts are not hoping that, it'll work so they can go back home.
So what you're saying is if we leave it running for a few years, there won't be enough oxygen for me to walk around and breathe?
No.
Oh well, it was a good try, Sarah.
But this little canister-sized thing isn't going to fully regas the planet.
No, but I love the technology demonstration. Honestly,
yeah, it's one of the.
It's so true. If we're going to go there, we need to be able to use the resources that are there, and they're different than the ones that are on Earth. So that is super cool. We're doing that test.
A little bit harder to get at than what we do on Earth. We don't.
And let's see, we got Pixel. Pixel is going to be the thing that identifies what they inspect with the inspector, Sherlock and Watson. And these are the two instruments that if there is fossilized life anywhere in the region, these are the instruments that are going to detect it. Sherlock.
Well, really? I'm curious if our guest, what Ken's going to tell us about that. So Sherlock and Watson are really going to do that, but let's not go there yet.
Yeah.
There's hypothesis we're going to go there, so let's not spoil any of the too much fun stuff.
All right.
Now that's a good introduction because I'm going to talk a little bit about the rest of the stuff that's in your slideshow there.
Cool.
Well, your slides might be better, honestly. So anyway, so thank you, Sarah. So we're sending a rover. It's a lot like one of the rovers we've sent before. Let me share the slideshow I have set up. Okay. Hopefully everybody's seeing that, although I'm seeing Sarah off to the side. There, I'm seeing all of us. I don't know what we're seeing. So we're going to skip forward. There's our guest. By the way, this was the slide I stole. It was supposedly open for use. Everything I've grabbed is open for us to use. But it was actually showing Mars going through the ages from 4 billion years ago. Some artists went in and thought, well, if it was filled with water, what might have it looked like? Now, I wonder, Valles Marineris, it is a very old feature, but was it really formed 4 billion years ago? Maybe in that time-ish range? But I don't know. I wonder about these things. So that's what that was all about. Somebody had questioned me, where's the green? And I thought, oh, they might be thinking this is a terraforming. I took out the dates. I had just shown the globes, and somebody thought, well, maybe we're terraforming Mars and turning the oceans back into it, and well, where are the plants if we're terraforming it? But no, this was Mars going from ancient Mars when there was water to current. Now, one of the reasons we think, well, there's water is all those missions that were there and are currently orbiting Mars right now. This comes from the Mars Reconnaissance Orbiter. Believe it or not, this is an image of Earth and our moon taken from Mars. I just think this image is so super cool. One, you can tell that Earth is highly reflective. You're seeing glint off the oceans and you're seeing clouds. That's something we actually see to see liquid on Titan, believe it or not, a moon of Saturn. We see the sunlight glinting off the liquid. We're seeing continents, so very interesting. And then the fact that the moon is that large and you can get it in one shot like that from another planet is pretty darn cool, I think. So I had to include it. The Mars Reconnaissance Orbiter is still there taking amazing images. It helps us plan other missions. We have the InSight lander on Mars right now trying to, well, one, it's measuring Mars quakes. Every time Mars has a little earthquake, every time there's an impact, a little meteorite, well, a little minor asteroid smashes into Mars, makes a tiny crater. It's picking these up, and it can tell the difference between an impact and when Mars is just sort of rearranging itself very deep inside. And the quakes are different than they are here on Earth. They're more like fractures, and they think Mars itself is extremely fractured underneath, much more broken up than Earth is. And the data are consistent with that sort of measurement. Another instrument that you see in this is the mole. And the mole they've been having trouble with, and it is animated, I hope. That's pretty great here. There's actually a rod about this long that has a hammer built into it. Goes up and springs back down, and it was supposed to drive itself down into the ground about, well, several feet down at least. They were hoping to go about 10 feet down and measure the temperature down in Mars. Well, it's stuck. And if you notice, right at the end of this, you'll notice the sand in the scoop starts to vibrate. That's a bad sign. It means it probably has come back up and is banging against the bottom of that scoop. But the Mars InSight lander is giving us weather reports from Mars. It's a fun resource. You should check it out. But now on to the rovers. These are the rovers some of the rovers we've sent. You can see the little Sojourner there, and then Spirit and Opportunity, one representing both of them. The smaller one about golf cart size, and then the larger Curiosity rover. And to put them into context, there they are, I think in the Mars yard, probably at JPL, and then add some folks, a couple of guys, you can put them into context. That's a big rover. Curiosity's not small. Anyway, okay, the slide that I thought was going to be.
It's about the size of a small SUV. Think like a Mini Cooper RAV4. It's about that footprint.
Yeah, that's the wheelbase is actually is shockingly wide, and those wheels are really big. Later, I have a picture of me holding one up. I'll watch when it's all torn up. So anyway, when we sent Opportunity and Spirit to Mars, right away when they landed, they started seeing evidence that Mars once was wet. That was one of the questions they wanted to answer. Did Mars have long-term standing water on it? And if it did, what were the conditions like, basically? And this is the Eagle Crater, where I think it was Opportunity came to a rolling stop there, and immediately saw these striations in the side of the hill, the little crater, and saw these things called blueberries. Well, they're not really blueberries. They're hematite, which is formed generally in standing water. It's a mineral that forms in layers in water. Anyway, it forms these little things nicknamed blueberries. I do love blueberries, so yum. And that's a real picture. It was taken of them, and everybody was thrilled to think, wow, well, these can also form in other mechanisms, with other mechanisms. I'm not going to go into the details, but it's a strong hint that, well, maybe there was a lot of water here. Here's one kind of in that sediment right there forming. So clearly they're formed and locked in sediment for a while. The sediment has to get eroded, freeing these blueberries up. And then Opportunity drove on and then came across that weird little white thing. And that's actually gypsum. which gypsum is a lot like the stuff that's in drywall, believe it or not. So that looks like a sheet of drywall somebody buried in Mars. Oh my gosh, there's aliens doing sheetrocking of homes on Mars. No, this is a sign that Mars was wet. That a really, really strong sign. You don't make gypsum without water. I don't think there's good mechanisms to do it. So you've got the blueberries and this. It's almost a home run in terms of, yes, there was a lot of water there on Mars. Spirit got there, had a little bit of a harder time making amazing discoveries. One of the wheels locked up on the little Spirit rover, but that dragging wheel dragged across this stuff, and those are salts in the Martian soil. Salts. Well, where do you get salts? You get salts in things like hot springs. So that's kind of crazy. Hot springs on Mars, somewhere where you have warmth, energy, you have minerals, you have liquid water. That sounds like a pretty interesting place to me. I'm not going to spoil anything, because we got an expert on that sort of a thing here with us tonight. Maybe tell us why we were so excited about seeing that. But the Spirit dragged that wheel through there, exposing that stuff. So there's all sorts of amazing stuff buried right under a layer of dust, that orange dust that covers everything on Mars. You dust it off of rocks, you see what the rock really looks like. You drag your wheel through the dirt, you see what's really going on under the dirt. So there's all sorts of amazing discoveries on Mars. Then we use this crazy sky crane, parachuted in like we were talking about earlier, and then it ejects the back shell on the parachute, ignites its rockets, comes in, lowers the rover. I think we're landing Perseverance the same way, and it worked once, and they've gotten better at it, I assume. More troubleshooting, more running everything through all the tests. And this is at Curiosity after it landed in Gale Crater, started taking panoramas, and everybody loves the selfies. You wonder, how does it get a picture of itself? Well, it takes actually a camera, and it's a camera that's meant to take little shots. That's the little squares that are all stitched together. And you just take image after image after image and slowly take the picture. So sometimes it'll even image the arm right out of the shot. So you'll get some of these creepy shots where there's no arm holding it up and it looks like there's a person there taking the picture. There's not. It's just the way that the picture was processed. But what's exciting right away is Curiosity started to see evidence of long-standing water, things like stream beds. This cemented together dirt and gravel. That sort of stuff happens on edges of lakes and edges of streams. In fact, these pebbles on the left, the only reason I know that's Mars is it has some of the orange dust. It looks just like the stuff on the right. That's on Earth. So a cemented stream bed with pebbles that were smoothed out by flowing water. And this water, they estimate, was there a very, very long time. We're not talking about water that flowed a couple of years. We're talking, well, anyway, there's centuries and centuries, if not longer, evidence of water standing in Gale Crater. Now, there's also evidence of it coming and going, so it isn't necessarily there the entire time. And we're not exactly sure how episodic. That's part of what's still being solved by Curiosity, is it's driving up Mount Sharp. It's going up this peak. And you think the peak, is that the peak that was uplifted in the center when the crater formed? No, the crater actually formed, it was filled in with dirt and dust and all sorts of stuff that was eroded, leaving behind Mount Sharp. So we're actually seeing stuff that was left behind and layered in there over the millennia, so over billions of years, and we're able to go in and track what happened with water. Now, Curiosity, a lot of folks are like, well, why didn't it find life? It wasn't sent to find life. It was sent to find the environments that could be suitable for life. So there's a story to this. NASA had some exciting results. We talked about it at the beginning. Maybe life in this meteorite, maybe some other things. Well, public gets very excited about that. They want to know, is it or isn't it? And you get a little tired of having scientists saying, well, we're not sure, and maybe it's this. So, well, let's devise a plan of study to go really figure it out. And first, you go look for, was the water there? And then you go, was the water a good environment for life? And Curiosity answered that yes. That water we could have drank. We could have filled it up in a glass, had a glass of it, drank it. It wouldn't have killed us. Maybe it wouldn't have been the most tasty, but get a Brita, filter it. I don't know. Anyway, and here's another picture of Curiosity down there in Gale Crater. So it completed its main mission of discovering that Mars was indeed habitable almost immediately. And there's the wheel, me holding onto the wheel there. That's all torn up, and they've redesigned this a little bit. But one of the charming things about the wheel is JPL threw it in there that actually put out JPL and Morse code everywhere they drove. NASA got wise to that and decided they wouldn't allow it anymore. Okay, now I'm just forwarding with wild abandon. So let me see if I can back up here. Here we go. So on to Perseverance very quickly. I just want to show a picture that it's going to launch on what kind of rocket, Jared? Is that a Delta?
That is a Atlas 5 in the
Atlas.
541 configuration.
541 configuration to all the rocket nerds out there. So that's going to be fun. You don't hear of Atlas is flying a whole lot. So very reliable booster, though. That's one of the reasons it was picked, and it can carry something pretty heavy. So exciting to see it. There it is. There's the nose cone, actually. And I actually like the emblem they have there of the rover-looking thing with the star. Mars with almost the worm font, I'm not so sure of, though. We'll see. I love this. They did test the whole rover. It was tested in vacuum and other conditions down to temperature. Mars is very cold, but that's the actual mass cam coming up. There it is being loaded into that cone, so good fun. And here's where it's going. It's going to Jezero Crater, which is in northeast Syrtis. Zoom in a little bit here, star. Citus Planitia, you can see the depth. Indeed, this is deep. We think this might have been sort of an inland bay of some sort, and the crater's on the edge of it. And there's strong, strong evidence, as you can see there, of a river flowing in, leaving a delta in that giant bay of sorts. And in fact, there's an exit river over on the far side in the upper right-hand corner. You can see it there. So that's just some crazy stuff. And another sort of context showing mineral layers, and I'm not even sure what all that means, but you can sure see that stuff was layered in there, and I don't know, that's where they're sending this. Is it a good spot? Is that somewhere that you want to go send a rover and a helicopter? Yeah, there's going to be a helicopter too. So let's go to our guests now, because I've done enough of the introduction here. I'm going to stop our sharing. So Kennda, did they pick the right spot, that crater with that delta? Is that somewhere we should be going and looking for life? And did they pick the right rover? Is the rover capable of seeing signs of life? Because, Curiosity wasn't designed to do that. I don't want to get everybody all excited. If we're going to go find life, like Sarah was implying, is it going to actually maybe be able to get a...
Well, so Perseverance is not designed to necessarily find life. It's designed to find possible biosignatures of life, which is a big deal. Because if we find possible biosignatures of life, then that gives us, a lot of indication that life could have existed on the planet, and we may still possibly exist today, but we can get into that part later. But
you just drop something like that and move on. So,
no, we're not going to talk about that, because what Perseverance is going to a wonderful environment. It is absolutely the right environment in my mind as a astrobiologist. It's a great place for us to go and look. It's got a diversity of different potential habitable environments that we can go and look for possible biosignatures in. That's the beautiful thing about a delta environment, because we have the delta itself. We know it's in a Paleolake basin. We know that it was in this watershed that all this water flowed in. So we have all this different diversity of environments. And astrobiologists, we had a biosignature detection on Mars conference back in 2016, and we identified 5 key types of our most interesting habitable environments that we'd like to study. And Jezero potentially has the possibility to have all 5 of them. And so it's a really exciting environment. So I think it's a great place to go.
What are those 5 environments, if I may ask?
So we have what are called subaerial, like spring environments, subsurface, like groundwater environments, potentially hydrothermal systems, subaqueous, like the lake environment. And then what's the other one that I'm forgetting? So it's subaerial, subsurface, subaqueous, iron-driven, iron-dominated systems. It's Mars, so iron tends to be everywhere. And there's one more, and I'm trying to remember exactly what it was. I should have, I know, surface, subaqueous, subaerial, iron-driven, and there's one more, and I will remember it. But
I put you on the spot. Don't worry.
No. I remember it. I'll be able to sneak up, and I have a slide that has the whole list. But I just got to remember it and open it up. But yeah, it has an amazing diversity of environments. I can kind of go over. I can go over some of the environments that I'm really excited about. But the 2 biggest environments that we're really excited about is 2 parts of the lake. One part is what's called the delta bottom set deposits. And I'm very excited about that because that has to do a lot with my research. And the other part is this thing that everybody's been hearing about called the marginal carbonates, these kind of shoreline carbonates that kind of exist on the shore of the lake. And I can show you, and I'll let me pull this picture up for you. Let me make sure this is working right. Let's see. So I'm going to share my screen. Can you guys see Jezero? And can you guys see my mouse? Can you see my mouse moving?
Nope.
I don't see anything but you at the moment.
Okay. Oh, I didn't share. Sorry. There we go. There it is. Now can you see it?
Yep.
Yes.
Yes.
The mouse. Sorta, kinda.
Yep, we got you.
Yeah.
Okay.
And I'm gonna check.
So if you kind of look down in this purple region, kind of on the edge of the delta, that's kind of like the delta. That's kind of like the delta floor, and right around the edge there. And then if you see this little mountain spot that's kind of all the way far out, that's kind of like the furthest, what we call the distal part of the delta, the furthest delta, and that's where the delta bottom set deposits are exposed. And this is a really cool environment because this is where we have a high probability of organics to be preserved, and they can be preserved from 3 potentially habitable environments. They can be preserved from the watershed, which is where all the water that came to develop the delta and the lake came from. So that's stuff way up here, you know, going up this stream, and everything that added to that stream and basically made this final outlet that created the delta. There could be a habitable environment way up there that, you know, picked up some organics and some potential biosignatures and brought it down and dumped it into the delta and into those bottom set deposits to get preserved. It could have been from the lake itself. So if there was life in the lake, both just kind of out in the lake water, or at the bottom of the lake, it could have gotten preserved in these deposits, because these are really, really fine, small deposits that are very good at, you know, we learn on Earth that these are very good deposits that preserve organic matter quite a lot. Or for my research, it could have also been from potentially a what I call a transitional habitable zone, which could have been if there was any kind of subsurface groundwater moving through these deposits way back as Mars started to transition from wet to dry, because Mars, like David said, Mars, this surface water was episodic. We had one big period going from the oldest time of Mars called the Noachian to the kind of the middle time of Mars called the Hesperian. And in between that transition, we had this big period of surface water, right? But then it kind of went away, but then eventually it came back. You know, it came back and then it went away, and it came back and we had episodes, what we think are episodes of water going and coming on the surface. But in between, we had a lot of groundwater moving through the subsurface. And we see a lot of evidence that groundwater was moving through the subsurface of Mars a lot, you know, for a long time.
Right.
And so
Now,
if it was moving through these.
Quick question, and you know, driving through the Eastern Sierras, I grew up in Reno, and I still go up to see my parents up there. Hi, Mom. You see the tufa in Mono Lake and in other lakes where you have a spring that comes up into a lake. Those hot minerals form those towers. Do you think we're going to see anything like that here? We see evidence of hot springs. If this was standing long enough, are we going to see Martian tufa?
I don't know if we would see something per se like tufa. I don't know if the rock indicates that the geochemistry would be right for like, you know, for like Mono Lake type of super alkaline environment. But we do have the potential. We see things like hydrated silica, which could indicate hydrothermal, some kind of hydrothermal alteration. So some kind of hot spring might have been within the Jezero environment. We're not sure. We see evidence of it. We're going to have to get on the ground to really look and understand. But what's also, so that's that's another possible environment, is there could have been hydrothermal systems that could have been, you know, in the lake environment or around the lake environment. So that is a possibility. There also could have just been even regular springs in the delta itself that could, spring deposits that could have created habitable environments, you know, subsurface in the delta, kind of like on the top of the delta, there could have been a subsurface environment in the springs, and that could have put out, things that were preserved for us to find. And then finally, the really cool thing, and I'm going to switch to this other image here, if I can. You move me forward. Really cool thing here is you can see the purple stuff down on the edge here, and this other picture that I just showed you. That's kind of like, you know, the delta front. That's some of that bottom set deposits. The other cool thing is these yellow deposits here on the kind of on the edge of the lake. And those are magnesium carbonates. And these marginal carbonates could be what we call microbial lights. They could be like, for those of you who might know, you might know the word stromatolite. Like we always talk about the stromatolites of Australia, these really cool carbonate structures that microbes build in shallow waters of the ocean and live in. Well, the general called microbialite. Stromatolites are a form of microbialite. These magnesium carbonates, there could be microbialites in there that were formed by Martian that were living on the edge of this lake. So this is one of the areas that we're really excited to look at, as well as at the bottom set deposits. So those are two of the areas that I'm most excited about. And you can all see my future Mars researcher right here. My son Gavin has joined us. The joy of working from home.
Hello there. So quick question. I'm seeing just a couple of kilometer scale there. What's the landing ellipse like here? And Curiosity's gone how many kilometers now? I forget the exact number, but
oh my gosh,
we're going to be able to explore this whole area in here with Perseverance.
Ideally, yeah. I mean, ideally, yeah. The traverse, and I wish I could show you the traverse video. Let me move back. Sorry, equipment malfunction. Hang on just a second, guys. I got to get a dad in here.
That might be the future first man on Mars. You never know.
Be a good one.
Yeah, I hope this little one can go to Mars. That's for definitely sure. I hope so. Yeah. So, but yeah, if you look, I wish I didn't put a traverse picture in here, but ideally they do want, ideally the landing ellipse would be kind of out here near the bottom sets. The landing ellipse kind of goes all the way out to like just beyond these like mountains here, and then up into the upper region of like where the marginal carbonates are. And so we could land anywhere in there. And one of the traverses that I've seen the team put out most is that we kind of, we land over here somewhere where it's kind of flat and safe. We go check out these really distal deposits out here. We head to the Jezero bottom set front. We kind of traverse along the delta front. And then we kind of climb, and then we go explore the upper part of the delta, and then we try to, start to explore some of the marginal carbonates. And then we can kind of head up, and then at some point we might head up and out, especially in preparation for sample return. After we get past prime mission, Perseverance could head up and they're out to explore, possibly go to Midway Point, or possibly go explore more parts of the crater, and then traverse somewhere where it'll be able to meet the Mars sample return lander and drop samples or something of the like. So this baby can go really far for a long time. Our nominal mission is 1 Martian year, so that's about 2 Earth years, and the goal is to get from this distal point here and kind of get to all the major kind of big features of the crater and hit all the big targets that we're really, really interested in. So that's what we hope to do. We'll have to see what happens. Ultimately where we go and how we go, it depends on what, as we get closer and closer to landing, that those decisions will be made by the mission team and the engineers, of course.
So, all right. Well, this is super exciting. Now, you used a couple of words that I found greatly troubling when this whole mission was being planned, and that's sample return without a sample return vehicle. So, are there plans to tell the American public who likes their bling that, hey, we found jewels, we found platinum, and we've put it in these little containers? Now, of course, we're talking in metaphors. These are, samples that are as good as jewels for an astrobiologist.
Yeah.
But how are we going to get them back? Do you really think we're going to get them back in our lifetime?
I really do. We want to get them back. We want, the plan is to try to get them back. Sample return is already being planned. We're already working on the technology. The engineers are already working hard to figure out how to get down to the ground, how to collect samples in the event that we can't get to the samples that, all the different contingencies. How do we get down on the ground? How do we collect samples in case Perseverance can't get to the rover? How do we meet up? How do we transfer samples? How do we launch it back? How do we get it safely, back to Earth? How do we get it back on Earth safely? How do we do all of this and do planetary protection? All of that is going on now, and it's going to be it's going to be an international effort, and I really do think it's going to come back, because I think we all really know that the best way we're going to answer the question of are we alone is if we can get some of those samples back here and really a good study here on Earth with those Mars samples.
Well, I like the I'm going to stop your screen sharing here for a sec.
Oh yeah, please do.
Oh no, that's fine. No, again, we're all friendly here. I want to remind everybody out there that's watching, and I'm not sure how many. I think I might have turned the chat on. My friend Maria, hi Maria, that's out there, said the reason the chat was turned off is that I made it kid-friendly this time. I've always had kid-friendly turned off, and I was laughing like, we want to swear, we want to have cocktails. And then I thought, oh, let's make it kid-friendly. We're going to talk Mars, and I want to inspire some kids, the future, whatever. So in my, desire to be more broad reaching in this, I turned off the chat for everybody, evidently. So try now. I've made it again saying we're no longer kid friendly, so people might be able to chat. We'll see.
It does look live now.
As long as he can't see the chat, it's all good.
Yeah, no, we're still going to keep this one relatively clean, and swear it's only because astronomers have this bad habit of swearing like sailors. We're terrible. It's because we get on top of mountains and we think nobody's listening, and we're not. We're on YouTube Live in front of all 12 people that are watching at the moment. I don't know what we're up to. It was 20 some a little bit ago. 15. Yeah, no, there's always more that watch it in the long run. And welcome everybody that's out there. And the lack of chat probably just made people say, the heck with this. Now I've got some questions though, because you're an expert in hypersaline environments, and that you've studied these. I'm assuming, I read in Utah, so I'm assuming that's maybe around some of the salt flats. There's of course the Great Salt Lake out there. I go to Burning Man every year. I mentioned this already with the Black Rock Observatory, and it's on a great big huge dry lake bed. And when it rains, the lake does kind of come back an area, and it cools up, and there's these little shrimp that come out and rehatch and come back every once in a while. Now we know it doesn't rain on Mars. We know that fact. However, there are some weird features. There are these things called, I'm going to put this to gallery view, these things called recurring slope lineae. They're these dark streaks that appear. Now, people have been contentious about these for a long time. At first, some folks thought it might be things melting from the sides, but then they were seen on peaks of craters. They were seen in Valles Marineris in areas where they couldn't possibly be replenished by any sort of ice sheet or any sort of spring at the top. So some folks thought it was salt that was on the side, and you were getting deliquescence of the water forming there. But even the deliquescence forming, well, that's still forming liquid water on the surface, sitting there in little bits. And this is actually seen in some Antarctic salty lakes. There's a very, very salty, I think it's the saltiest lake on Earth. I don't remember the name of it. You can Google it. There's footage of some things that are very reminiscent of recurring slope lineae showing up. Now, myself, I also wonder, could they just be dust is going down the hill and it's being exposed? But then again, the way they disappear is kind of they go up and disappear as though the water is subliming away or I don't know. They're very strange things. But let me get to my main point here. If brines can exist on Mars, potentially in those, could there be a layer down underneath Mars where there's enough pressure due to the layers of dirt above you, you're protected enough from the lack of atmosphere that it all hasn't just sublimed away from frozen to gaseous, the water. And then if you have enough pressure, it could become liquid. And if you warm it up just enough, and that's something we don't know because that darn mole with the temperature probe of Mars, but could there be a layer under there that's liquid? I guess that's what I'm getting to. If you have enough salt in there, enough warmth, could there be? Yeah, what do you think?
So the answer is, it depends. How's that? So in the shallow subsurface, and my colleague Edgar Rivera Valentin actually just published a paper this summer looking at the stability of brine formation kind of in the surface and the near subsurface. And what he found in his work, and Roman Martinez, who is also one of my colleagues at LPI, and he is on the atmospheric instrument, the weather on MSL. So he works a lot with the weather and the temperature and the relative humidity data. And so, I've got some really smart folks I work with at LPI. They did some modeling, and what they found out is that you do get what we call metastable brines that can exist in the surface and the near subsurface, but they're so cold. Life as we know it could not survive in them. But this is this is kind of in the near subsurface in the first kind of like 10 centimeters or whatever. But what we do know and what we do think is that there are, there is a growing effort in the community to start looking into the deeper subsurface where more stable liquid water could exist. Now we're talking deep, like like hundreds of meters deep.
Yeah.
Where where liquid water could exist, so where we could still get some stable large scale liquid water, and we could have a large scale ecosystem. So so if you're asking, is it possible there could still be life on Mars today?
Yeah, that's what I'm asking actually.
The answer is yes, it's possible that there's still life on Mars today, but it would probably be deep in the subsurface where we can get large scale liquid water. Now, is it maybe possible that we might have smaller niches where we get more transient liquid water? It's a possibility, and that's something that we're trying. It's a possibility that we're trying to understand. Life as we know it, with the constraints that life needs, again, based on some of the work that colleagues have done, in that near subsurface, based on life as we know it, Earth-based life, anything Earth-based probably couldn't survive those metastable brines that form. But we need to have a better understanding of how more stable do those brines get as they go deeper. Is it something that life could possibly survive? That's the kind of questions that we are asking and answer. And the one thing I'll tell you is, I hate to quote Jurassic Park, is I never doubt life. After learning about extreme environments and everything I've learned about microbiology, life finds a way. So I just never doubt life's ability to figure out how to live someplace. But
I love hearing you as an expert. You as an expert saying that gives me hope. Just I don't have any expertise in this at all, and I feel that way. So you saying it, I can now be like, my friend that's an expert in this says. So no, but we do have a question from, I'm sorry to interrupt, but we have a question from our YouTube audience. They want to know, why did the edge of the delta look like a cliff? It looked very sharp on the edge there in Jezero Crater.
Let me pull that picture back up, because it's been eroded, right? So it's been exposed. Okay. It's been exposed for, and I have a more. I'm gonna. All right. Here.
Yeah. You bring that up, and I'll continue to get excited about the fact that, one, we just got you to say there could be life on Mars today, although it's pretty deep, so I don't know how we're going to go down there and say hello. I know, but I've always felt that is a possibility. And again, folks out there, don't go crazy with this, because one, it means that it's potentially could be there. It doesn't mean it is there. It means that if the conditions are as we think they might be, then yes, it is plausible you could have a layer in some places that might still be liquid and could still maybe have life, if life even formed there in the first place. So let's just get very clear about what we're talking about.
A lot of questions to still answer, but it's in the realm of possibility. It's not complete, it's in the realm of possibility. We still have a lot of things to figure out, but it is possible. It could, do we know it's there? No. That's
I'm gonna drink that. So question was, why does it look so sharp? And I think you've got a great
it's because the delta, everything on Mars has been dry, and Mars has been dry for a very long time. So we do, just like on Earth, Mars has weather. It doesn't have rain, but it has a lot of wind. We have windstorms. We call these aeolian processes. So we have a lot of wind processes. So things do experience erosion. So this delta probably was a little bit more smooth and a little bit more flattened out back in the early formation, like what you'd expect to see even a brand new fresh delta on Earth. But it's been weathered away over time. So this is kind of what's left, and you can kind of see in this more high resolution image of kind of what pieces of the delta front kind of looks like. It's not quite as sharp when you can kind of zoom in. You can kind of see there's a lot of dunes. It looks a little bit more sloping, but it has been weathered. So
okay, very interesting. Now there looks like there's a sharp line in that image in the lower right.
The lower right.
Yeah.
That looks. Oh, those are probably. My guess is those are probably. I'm guessing grabens of some sort.
Yeah, they look like cracks.
Yeah, probably grabens. I'm not the geomorphologist, so but that's probably what they are. They're probably cracks. We call they call them grabens, or that's what that kind of looks like down there. So
yeah, very cool. Now, oh gosh, this was years ago when these sites were up for. All the sites they were trying to pick, they put them out there. We're now narrowed it down to 4 or 8 or whatever it was. I could not find high-rise imagery of Jezero Crater. It was difficult to go find that high-resolution stuff you're showing now. When was all that taken? Did they go in and panel that since then?
So yeah, when you're doing site selection, and I actually am participating in the site selection, just as a quick side note, I participating in the site selection process that has begun for the first human mission. So we've only had one meeting because it's going to be a while. But what happened after that first meeting is that they give all the sites that are proposed, especially those that kind of move through the process, they give them an opportunity to get some more higher resolution data. So they get their sites prioritized for HiRISE and for CRISM data off of the Mars reconnaissance over.
Okay.
You don't get a lot. I mean, it depends on the mission, but you get, as your thing moves through the process, you get more, priority to get more images to help make the case for the site as you progress. So
Right.
A lot of the images have, been added as time progressed, and it looked like, continued to be a candidate. All the sites that continue to progress through each of the meetings, they got additional images to kind of help analyze, the sites, because they not only have to consider the science, we also have to look at the engineering. And engineering also drives landing heavily right now, as we talked about earlier. So a lot of the drivers, I mean, if you looked at a lot of the sites, they were all in craters, and that's because we needed all that space to slow down. So that's, if you didn't meet a certain elevation requirement, your site was out, so things like.
It's a good thing water flows downhill.
Right, exactly, right.
So, now
yeah.
you said you were on site selection for the human mission. Now I'm sure you can't tell us, and there's no details on this, but timeline for that. What are we still looking at to get to Mars? Do you think we 20 years out at this point? Like really?
The timeline they told us at the meeting, it was the first time in my career, and it's right there. It's right there on the website. It's not a secret. They told us 2035 was the target shoot date.
They're still shooting for 2035. Okay, well,
that's what it says. They haven't updated it, but it's important that it's the first time in my entire NASA career that I actually got a date. Starting from in college, when I started working at NASA, it was, we're going to Mars in 30 years. And I kept hearing that, in college, when I was working, and 10 years later when I'm in grad school, and, and then, and up until this first meeting when they're like, we're going in 2035. And I'm like, wow, we have a date. I'm excited. So,
yeah.
In my mind, NASA's committed because they actually put a date to it. So they got put a little bit of pressure on themselves. And we are really working towards understanding where a good site is for human landing. And that's where the ISRU instrument is important, because one of the things that we need, again, is we need water. So we need to land at a place where we can really extract enough water out of the site. And so that's one of the big criteria with respect to site selection, is we're looking at places where we either have access to water ice, like we actually get ice, subsurface ice, or in the permafrost, or out of the aqueous minerals. So
yeah, I think I showed that picture before, showing whether it was in this show or All Space Considered. I know that the northern and far southern latitudes of Mars have long been thought to have water ice under the surface. We see fresh craters that have white stuff around them that then disappears after a period of days or weeks. And that's clearly water in my mind. And then, of course, you see the North Pole, South Pole has, water deposits that are there. I guess the north one is.
Yeah, both poles have water ice, and they have CO2 caps on them.
Yeah, CO2 caps come and go. But then, of course, you had the ground penetrating radar and neutron results that are showing there's that water ice under there. So, and then the Phoenix lander goes there and exposes right under it a couple of, it looked like, home plates of water ice right under the rockets where it landed. And so, yeah, the water is there. It's there for the grabbing if you go to the right spot. But it's frozen.
And not only in the ice, but and that's kind of the challenge, is if you go too far into the latitudes, it gets harder and harder to keep humans warm and so, we are also looking at aqueous minerals. And this is one of the things I wanted to follow up, because you showed the gypsum from Opportunity, Spirit and Opportunity. And I wanted to show you that after that, the Mars Reconnaissance Rover launched, and we started with CRISM, we started seeing lots of aqueous minerals everywhere. And I want to show you my favorite site that is also the human Mars landing site candidate. And that is, let me pull it up here. I'm gonna, here is, sorry. That is this beautiful crater right here. This is Columbus Crater. This is our candidate site where we would love to send a human Mars mission if we can keep passing the criteria as we move forward in the process. And what's really cool about this site is it's got a lot of aqueous minerals in it. Let me, so you can see it's got a lot of aqueous minerals, and here's kind of how we laid out our landing site. So you can see here's all the detections. All those spots are places where there's aqueous minerals. And
now, aqueous minerals, you mean minerals that have
water. They were
as
formed
part of
by
their
water.
structure.
Yeah, and they were either formed by water and they may have water in their structure.
Okay.
So like, and the biggest thing is you see everything in Oregon we call a science region of interest. You see that the entire crater is circled as a science region of interest. That's because the rim of this crater has a bathtub ring of gypsum, a huge bathtub ring of gypsum in it. It is so cool.
That's fantastic.
Yeah, so this is one of my favorite sites, and you can see all the kind of the detections if you just kind of look at that little white spot, polyhedral cephalates. You see it here, all the way around the crater. So that's kind of one of my favorite sites that I'm working on with my team to put forward for the human Mars landing site.
Now, if I'm not wrong, doesn't dolomite have a heavy gypsum content in it as well? Is there any dolomite on Mars? Because it's the White Mountains and again, this is my Eastern Sierra knowledge. Going up the Eastern Sierras, you have those white mountains off the side. They're white. Is that the same mineral that's in them?
No,
I'm not bringing up dolomite for any reasons other than
is a
Netflix special about the actor.
dolomite is a magnesium calcium carbonate.
Oh.
So, but dolomite's kind of neat because it's a magnesium calcium carbonate. And it's kind of this neat thing that not only from an astrobiology standpoint, it'd be interesting to see. We have a lot of interest, and I'm not going to go too far into it because there's still a lot we don't know. But we have a lot of interest in dolomite from a geomicrobial standpoint. We're very interested in do microbes help make dolomite or not? We don't know. So it's something that a lot of us ask a question about. So dolomite's kind of a neat problem. I don't think we have.
That's why it's so bright white on those mountains. That's why the White Mountains, the magnesium content, I would imagine.
Dolomite does form definitely abiotically, but there are instances where dolomite may be formed in certain environments with the help of microbes. But we don't know that for sure yet. That's a big question. That's a big question
there's a
in the geomicrobial world.
But to go back, there's a gypsum layer all the way around this crater. That implies, was it a huge inland sea or some sort of giant ocean?
It may have been a giant deep water paleo lake that was groundwater fed. What we think happened is that groundwater upwelled and made this huge crater lake. And what we don't know is if that gypsum was part of like an alteration rind, or if it was kind of like, like the lake got infilled and then excavated or something like that. We don't know. But we do know that the potential indication, especially with all the other aqueous minerals we see, is that this was possibly groundwater fed and a very, very deep groundwater fed paleo lake basin. The only reason it is not a rover potential landing site is that it's not at the right elevation. It's too shallow, it's too high. So, but for human missions, it's at the right elevation because human missions right now, based on the reference mission, they're going to have an even more powered descent so they can land at higher altitudes.
Right.
I have a question about the crater. So the science region of interest, they were labeled in orange. There was a gray circle around the mountains.
Let me pull that back up for you. Yeah. So because this has to do actually with MOXIE for sure. Yeah, I know where you're going, and I forgot to mention that. So I'm going to share that screen again. So this gray region of interest here is what we call our resource region of interest. Here, hang on, sorry.
No, thank you.
There it is. This gray area right here at the mountain, that's what we call our region of interest. And what we had to do is we had to show where we could access resources for ISRU and water recovery where it was very easy. So things like sand dunes, finds, things that basically the astronauts or a automated mining rover could go scoop up, come back and dump in an ISRU unit easily without a lot of effort. And so we made this mountain, I call this the central peak in the Columbus crater. There are a lot of, I don't have a high resolution image here, but if you look at the high resolution images that we've done when we analyze the site, there are just a ton of sand dunes, what look like dunes all the way around the mountain. And when we look using the CRISM spectra, which tells us about the mineralogy, we see a lot of aqueous hydrated minerals in those dunes that would potentially be useful for ISRU. So that's why this is called our resource region of interest. And then everything else is kind of more science.
Very cool.
Yeah. So we still have a lot of work to do, but it's really exciting to be able to participate in this process.
Yeah, no, that is fantastic stuff. Well, thank you so much for coming tonight. Let's go look at our chat stream again and get some more questions. Since we had the chat off tonight, we'll go a little long tonight and let them ask them.
You forgot to ask me about 42.
I'm tempted to make Marty the Martian a chat moderator. I hope nobody out there finds. I have no idea who this person is. And
He said tomorrow.
is he? Well, that's trustworthy for sure.
Yeah. Oh yeah, he's a good friend of tomorrow.
Well, Marty, and if you keep coming to the show, we may end up making you a moderator for our chat stream. I'm so sorry we had that off on everybody earlier tonight. Not my plan. I really just thought I'd make it kid-friendly tonight, and who knew that would make you unable to make kids? Apologies.
Okay,
anyway,
well, if he's not gonna, I'm gonna ask you, what is 42? What's it mean to you?
I always get there, but yes. So let's first of all, on Twitter, everybody should follow Kennda on Twitter. You're at MarsGirl42.
Yeah.
So is that the answer?
It is the answer, but and this kind of comes to our discussion about Black Lives Matter as well earlier. I am a big softball player, and it also happens to be the number of of Jackie Robinson.
Indeed.
A long time ago, most of my softball jerseys have the number 42 on them.
Fantastic.
Now, I'll be honest with y'all. I know out there for all of y'all out in California, that's exciting because Dodgers and all. I myself I'm from Chicago, so I love. But Jackie Robinson is definitely one of our role models, and I was so elated to find out, as somebody who loves the Hitchhiker's Guide and also plays softball, to find out that his number was 42.
Well, I think that's super cool, and it's wonderful you have it on your Twitter handle, and also Jackie Robinson. Just what a trailblazer, and truly led the way. And in some ways, I think you are as well. I hate to say it, but the sciences are not an easy place for women, first of all, and then people of color as well. It's not the easiest thing in the world. So I know that things appear to be changing, and I hope they do, and I hope they start to get better, and I hope we start to listen to everyone's voices that need to be listened to right now. And I think right now that includes you. So thank you so much for coming on and getting your voice heard and letting us hear the awesome science that you're doing. And I don't know, you better believe you're going to get a call from us as this the Planets and Humans keeps coming along, because we have an insider in here now. So
well, there's a lot of, and I can share it with you, so you can share it with. There's actually a lot of Google Hangouts about the process. I will send you the link so you can share it, with your viewers. And I was actually on a Google Hangout with a couple of other scientists. Bryony Horgan, who's a co-I on Mars 2020, also presented a site as well, and is participating in the human process too. So there's a lot of cool things. They have a lot of cool engineering discussions about the engineering challenges and stuff like that for the human mission. So I definitely want to encourage everybody to kind of follow that process, because we're doing Mars sample return, and then we're paving the way for humans too. So it's going to happen.
Yeah, absolutely. That's the thing, is we're in a time right now where getting to Mars is getting real. I always wanted to go there. I always wanted to see people. Well, not me personally. I'm actually not somebody who wants to go, but I want to see humans on Mars. That I find to be very, very inspiring. And also, human there can go do things and look at things and investigate things that even our best rovers can't quite do. And just well, I know I'm very pro rover as well, and I've seen those awesome dynamics ones doing the flips and all. But
even when we send humans, we're going to still have robotic assistants to do the really dangerous stuff.
Yeah. So, everybody's favorite part of Interstellar was TARS. So
well, but also just imagine trying to control a robot on Mars. It goes and finds something interesting, sends the signal back to Earth. Then you have to program it, send the signal back, say go do this. If you're there on Mars with it, it's all real time. You aren't waiting for that delay for communication and planning. You can be doing it with two-way video. You can go up there, move the drill up, dust it off. Oh, that doesn't look like the right spot to drill. Move it over, dust it. Oh, that's what we want. There's the gypsum. So there's the dolomite. Let's see if it was formed by bacteria, by life. So anyway, thank you again so much for joining us. And I'm not seeing any other questions out in our chat at the moment. But yes.
Well, there are goofy ones.
There are goofy ones?
Yeah, for like Marty the Martian wants to know. Let's see. Where was it? Oh, yes. If you want samples from Mars, should I send you my Iridium Q36 explosive space modulator?
Okay.
Okay, well, I think we've reached to the end of this. So, in any case, though, very exciting for you to bring us everything you've brought us tonight. You've even made me excited about the sample return of Perseverance with your enthusiasm that we'll get it done. And I think we will too. I think if we get something interesting and we get people excited about science and get people, Sarah, you're saying no. I don't know.
I think we're going to have people on Mars before we get that sample back.
I don't know. The way
Even if it's not NASA. If Elon has to like light some nukes to
he's losing his mind though. Did you see that
He
beautiful
really
image
is.
of Neowise with all the Starlink satellites across it? Anyway, we've gone there too many times. We've pissed off him. Well, he's never seen
Yeah,
it.
but
Or
we're
we
not
can't-
we're not bitter about it at all.
No, well, I'm not interested in having him as a fan, to be perfectly honest, if I have to say that. He's done wonderful things for rocketry. He's been innovative, but this just goes to show sometimes folks that are geniuses in one area are not always worth listening to in all areas. So let's keep that in mind as we move forward in America. I think we could use a little sanity. Anyway, thanks everybody for joining us. I'm going to turn off the stream here if I can figure out how to do it.
Thank you so much for having me. I really enjoyed my.
You're very welcome.
Thank you for coming.
Thank you
It
for
was so
coming.
great to meet you.
Yeah,
Thank you guys as well, all of you. This is fun.
And stay in touch, and folks will pass along some of that information about the Google information about the human selection site that you're going to share. So stay tuned on our YouTube channel.